Okay, so the question that we're going to answer in this video is, how do I write interval notation? I get this question a lot in my classes, and if you're in any sort of college level math class, this can certainly come back to haunt you if you're not good at writing interval notation. So you see I've got three different inequalities on the screen. Let's go through each of these individually. Starting with the one on the very left, x less than 3. I really think that, and this is just my opinion, but I really think if you graph the inequality on the real number line first, that the interval notation comes directly from the graph. So if you draw your real number line, of course you have 0 right in the middle. And remember that the arrow pointing all the way to the left is pointing to negative infinity, and the arrow pointing all the way to the right is pointing to positive infinity. And so this doesn't have to be exact, but 1, 2, 3 is somewhere about right there. Now, reading this inequality, x less than 3, right? So less than indicates on the real number line to the left. So what this inequality is indicating is we want to shade in all values to the left of less than the number 3. So I'm going to shade in all of the numbers to the left of, right? And we would go forever if we could in that direction. All of the numbers to the left of 3. And since there is no underline, right? It's not underlined. It's just strictly less than. That means that we do not want to include the 3. Now sometimes what you'll see people do is put a big open circle at the 3. Instead, I'm going to use a parenthesis, because the parenthesis is what we're going to use in the interval notation. Now, just like you read anything else in English, you're going to read this graph starting at the left and going to the right. Right? So the leftmost number where we shaded in the graph would be negative infinity. I didn't come all the way, but I could have continued this all of the way to the left. I probably should have. Right, so our leftmost number is negative infinity. And going as far to the right as we can that's shaded in, we would stop at 3. Right, and we know now that 3 is going to get a parenthesis because we used that on our graph. And you have to remember that anytime you write the number infinity or negative infinity, you get a parenthesis. So this is the interval notation that matches x less than 3. Okay, so let's do the same thing for this second inequality. If we sketch out our real number line, we've got negative infinity over here to the left, positive infinity to the right, 0 in the middle, and negative 2 is somewhere around in there. Now this inequality is x greater than negative 2, greater than or equal to negative 2. So greater than means to the right of, and the underline means also equal to negative 2. So we want to include negative 2 and also everything to the right. Let's just carry this out as far as it'll go. Now on the last one, we didn't have the underline, so I used a parenthesis. On this one, we do have the underline, and to indicate that the 2 is included, I'm going to use a bracket. Sometimes you'll see a closed circle used, and that's okay, but the bracket makes sense because that's what we're going to use in the interval notation. right? So again, read the graph from left to right. The leftmost piece of our graph is at -2. And if we get used to the bracket notation, then we know on our interval notation we have to use a bracket. And we go all the way to the right, and the rightmost number is positive infinity. And infinities or negative infinities always get a parenthesis. Right, it wouldn't make any sense. Sometimes I get asked, why can't we do this? Why can't we put a bracket on infinity? Well, because if you think about what the bracket means, it means this number is included, right? So you're at the -2, but you can't go to the left of -2. Right? So if you thought about if there was a bracket at infinity, that would mean, well, when you get to infinity, you stop. But that's kind of a contradiction. You can't get to infinity and then stop. So you're inventing some kind of strange philosophy if you write this, right? It's got to be a parenthesis, which allows for the idea that numbers get bigger and bigger and bigger forever. Right, so we don't want strange philosophy interfering with our precise mathematics. Right, so let's do this last one over here relatively quickly so my video doesn't get too long. Again, we've got the negative infinity and infinity on the left and right. You don't have to write that. I'm just trying to emphasize that those are the numbers out there. And so, let's see. -7 over here and 2 right there. Right, it doesn't have to be exact. As long as we have the idea of how to draw the interval, that will give us the interval notation. Right, so the way I like to think about this one is we want to shade in literally all the numbers that are in between -7 and 2 because the x sits in between -7 and 2. And so if we go ahead and think about it like that and shade in all the numbers between -7 and 2, and also notice that this inequality has an underline, which means we're going to include -7. This inequality does not have an underline, so we don't include 2. That's how the graph should look. And so now if we read this inequality appropriately, -7 is less than or equal to x, and x is less than 2. So any number in here, right, x is in here somewhere, right? -7 is less than the x, or to the left of the x, and x is less than 2, or in other words, x is to the left of 2, all at the same time, right? So that's the idea of this compound inequality, right? Two inequalities combined. And so if we just read left to right, the leftmost number is -7, the rightmost number is 2, and we included the -7 and did not include the 2. So hopefully that helps. Of course, the way you get good at this is you practice, practice, practice.